Hi guys, my name is Sharvin Analegi Kaleselvan. My metric card number is 25DDT19F1130. Now I am going to do a presentation for case study for subject network security. Lecturer for subject network security is Madam Hanis Basira binti Habu Hassan. Part 1. Identify the devices. Identify the devices that will be inside the diagram. Okay, the first is router router, which is Cisco 19141 dash sec slash k9 router. So we got three routers in our diagram. Second one is Cisco C type C2960 switches, which is we got two in our diagram, and we got Lenovo Idea Center 5 AMD PC in one in our diagram, and other is Lenovo ThinkStation P720 tower, which is server. We got one also in diagram. Okay, next part 2, explain the devices in detail. Okay, first is about router. The brand is Cisco, and you can see the model name is 1941 slash sec dash sec slash k9, which is a Cisco router ISR G2 security bundle. That's why it's called sec. And the total price of three router is RM 6,818 ringgit 58 cent, which is per unit cost 2,272 ringgit 86 cents. Okay, now let's see the specification. We got interfaces to integrate Ethernet ports, which is gigabit 0/0 and gigabit Ethernet 0/1, and we also got exponential slot, which is three exponential slot, which is two goes to enhance high speed one interface card slot, and another one for internal service module slot. Okay, this router got DRAM memory of 512 MB installed, but you can upgrade with maximum capacity of 2 GB, and we got flash memory of 256 megabyte installed. If you want to add, we can add until 8 gigabyte. Okay, and next about routing protocol. This router got OSPF routing protocol, OSPF IS BGP EIGRP DVMRP PIM SP GIM PV3 GRE PIM SSM static IPv4 routing, static IPv6 routing. These are the routing protocols we can use in this router. And data, we got data link protocols such as Ethernet, fast Ethernet, and gigabit Ethernet. Okay, next device is about switch. The brand switch uses Cisco. Model name is WS-C2960 plus 24 pieces uh, pieces of what fast Ethernet and catalyst, and the model name is Catalyst 2960 plus switch. Okay, the total price of two switches is RM 8,152 ringgit and 66 cents, which is per unit cost 4,076 ringgit 33 cents. Okay, we got a Ethernet interface, 24 Ethernet interface, uplink interface. We got two available PoE power is uh, 370 watt, which is we can access 24 ports, which is up to 15 15.4 watt. Flash memory got 24 megabyte, and DRAM memory of 128 megabyte. Okay, forwarding and bandwidth, we got 16 gigabit per second, and maximum active VLAN in per switch is 644 VLAN. We can also VLAN ID available in 4K. Maximum transaction transmission unit, which is MTU, we got 9000 byte for L3 packet. We got jumbo frame, which is Ethernet frame, which is 9018 bytes. Forwarding rate of 64 byte for L3 packet, and millions of packet per second, which is 6.5. Okay, and next is about server. The server I use in this mm, diagram is a Lenovo. Model name is ThinkStation P720 Tower, which is each oh, uh, priced cost for each is 8,995 ringgit 84. I used one server only in this diagram. Okay, let's see the specification. We got processor for the server is in Intel Xeon server 4210 processor, which is fourth generation. The processor got 14 megabyte of SAC and up to 3.2 gigabit hertz with memory boost. Operating system for server is Windows 10 Pro. Memory installed in server is 8 gigabit DDR4 200 2933 megahertz, and graphics fixed in server is NVIDIA Quadro P1000, which is 4 gigabit, and storage installed in server is 1 TB hard drive, which is 200 uh, 7200 RPM, and the size is 3.5 SATA 3. We got 3 years of warranty. The motherboard is P720MB Intel Pure dual CPU. Network card is 2 time, got 2 ports of integrated Ethernet, and got a power supply of 690 watt. Okay, now let's see about the PC. The PC brand is Lenovo. The model name is Idea Center 5 AMD. The price of each unit is uh, 2769 ringgit 20 cent. I only use one PC in the diagram, so this is the price of one PC. Let's see the specification. The processor in this PC is AMD Ryzen 7 4 4700G processor, which is fourth generation. Got 8 core and 64 threads, and can use default by this processor got default of 3.6 gigahertz, and can use up to 4.4 gigahertz with max boost, and 4 MB sachets L2 and 8 MB sachets in L3. The operating system in this PC is Windows 10 Home. The memory used in this PC is 8 gigabyte DDR4 3200 DDR4 UMD, which is 3200 megahertz, and storage is 2 terabyte. Optical drive is slim ultra bay DVD RW. Warranty for this PC is 2 years premium care, and the AC power supply for the PC is 260 watt. Part 3. Propose the network diagram. In part 3, I'm going to show you guys about uh, logical diagram, physical diagram, and addressing table. First, we start from logical diagram. This is the 3 rotors, which is I already shown in part 1, and the 2 switches, and 1 PC, and 1 PC in inside network, and 1 PC in outside network. Okay, now let's see our physical diagram. Okay, this is a PC which is in inside network. Okay, you can see R2, R1, and R3, switch 1, server, and switch 2. Okay, this is my physical diagram. Okay, now let's move on to the addressing table. Okay, we got 5 devices in addressing table. We not included the switch. Okay, first is R1, the interfaces and IP address which is got in R1. Okay, this is R2, the interfaces got in R2, and the IP address and subnet mask for each interface. For R3, we got two devices, two interfaces, same as R2 and R1. The interfaces, IP address and subnet mask for each interfaces. Okay, in server 1, this is the IP address, subnet mask, and default gateway for server 1. And in PC1, we got this IP for PC1, subnet mask, and default gateway for PC1. Now we are done our part 3, so let's move on to part 4. Demonstrate the firewall net flow. Okay, here got 4 situations. Let's start from top here. A net flow from outside network to inside network. Okay, let's see the net flow. So first we have to change to simulation mode. Okay, edit filters PNDNS. Okay, edit filters DNS and ICMP. Okay, go to PC1. Okay, give IP config to see the IP address and copy it. Okay, so net flow from outside network to inside network. So I ping uh, to R to I ping to PC1 from R2. So go to CLI, enable ping, and okay, let's see the flow, network flow. As you can see, the packet has been blocked in R3 because any outside host cannot access inside host because in R3 got configured ZPF on as an edge router R3, so any host from outside network cannot access inside network. Okay, let's observe second net flow now. So go to real-time mode and simulation. Okay, so now I'm going to net flow from R2 to server 1. So go to server 1 to collect the IP first. To get the IP first, okay, copy the IP. Okay, go to R2 and ping the command. Ping the IP of server 1. Okay, let's ping it. Capture forward. Capture forward. Capture forward. As you can see, the packet net flow is successful because it's in same network. The R2 and server 1 is in same network, so it's didn't have any blockage in R1 or S1. Okay, we are done our second situation. Let's go to the third situation, which is about net flow from inside network to server. So let's move to real time and simulation. Okay, now I'm ping from PC1 to server 1. So okay, I already get the server 1 IP, so I have to ping. You can ping by command prompt or a web browser also. Okay, paste the IP and let's see the net flow. How's the net flow? Capture forward, capture forward, capture forward, capture forward, capture forward. Okay, okay, you can see net flow from inside network, which is PC1 to server, is successful because the inside network can connect to out network uh, out network because ZPF has been configured on R3, so any inside network can access outside network, but the outside network only cannot uh, access inside network. Okay, so we are done our third situation. Let's move on to final situation, which is net flow from inside network to outside network. So I'm gonna ping from PC1 to R2. Okay, let's see. Show IP empty brief. Okay, I'm gonna take this IP. Okay, okay, let's capture forward to see the net flow. You can see the net flow is successful. Can ping to R2 because same as third situation. Inside network can access to outside network, but outside network cannot access to inside network because ZPF has been configured on edge router R3. Okay, you can see the ping also. This is third situation ping. Okay, as this is ping for third situation. Let's see for let's wait for ping for this situation. You can see the I think the ping is successful because you get uh, successful in first reply. So the first net flow is unsuccessful because net flow from out network cannot access to inside network, but all other three net flow after that can successful because the second situation is uh, in same network. The third and fourth are same because inside network can access outside network from any limitations. So I'm done my case study for network security. That's all from mine. Thank you very much.